Hi, my name is Dylan Horton, and this project is benchmarking network services using the Powder wireless testbed. Motivation behind this project is based on network slicing. 5G radio access network slicing provides a way to split network infrastructure into self-contained slices, which consist of various virtual network functions, which have to be mapped onto physical nodes in the network. A lot of prior research has gone into developing robust resource allocation and mapping algorithms for mapping these VNFs and embedding them into the physical network. But in order to efficiently embed the virtual network functions, we need to understand the resource and bandwidth requirements of the services we're trying to embed. The goal of this project is to analyze the resource and bandwidth requirements of 3 commonly used network services for use in these embedding algorithms. In order to do this, we use the Powder network testbed, which allows us to compare the performance of network services using a real-world LAN environment. We tested 3 different commonly used network services: email, network file sharing, and domain name system servers. Each network service was put through a testing scenario where we gathered data such as bandwidth usage and CPU load on the server nodes. Each testing scenario consisted of 4 user nodes connecting to the server node and using its provided service continuously throughout the course of the 15-minute test. The goal was to simulate a high traffic scenario so that we could gather sufficient data on the resource and bandwidth requirements of the network services. The bandwidth usage data was collected using the VNstat tool, and it shows the average transmitted and received data rate for the network services over the course of the 15-minute test. NFS and DNS both had relatively low data rates over the course of the test. This translates to low bandwidth requirements while embedding for network slicing. On the other hand, email had much higher data rates for transmitting and receiving, so it would have much higher, stricter requirements for embedding, and it would require the physical node to have a high bandwidth capacity in its connections to other nodes. The CPU load average data was collected using Powder's built-in tools, which queried the server nodes every 5 minutes to get CPU load data. Over the course of the 15 minutes, NFS had the highest impact on the server in terms of CPU load. This means that when being embedded, it would need a physical node with higher computing resources than the other 2. Email was second, and DNS was in the last and requires very little computing resources, and so can be embedded fairly easily. Overall, DNS had the smallest resource and bandwidth requirements and could easily be embedded in any of the physical nodes for network slicing. Email and NFS both had stricter requirements and would require an embedding algorithm to embed them in physical nodes, which could meet those requirements, whether it be higher bandwidth capacity for email or higher computing resources for NFS. Further research could involve expanding upon the current dataset and testing more network services in order to provide a broader analysis of testing network services. Another potential avenue of research could involve using the collected data to develop more efficient embedding and mapping algorithms, and then test their effectiveness on the Powder testbed.